Okay, so in this video we're going to talk about multiplying and dividing significant figures and how we need to round our answers when we multiply and divide. But first we need to review over what we talked about yesterday. Significant figure rules, what makes a number significant, and when we add and subtract, how are we supposed to round our answers according to our rules of significant figures. So first, when we're talking about significant figures, there's certain rules we go by. If we have any non-zero numbers, like we had 243, our rule says that all non-zero numbers are significant. So if I ask you how many significant figures this had, you would tell me that would be 3, because all those numbers are non-zero, so that would be 3 significant figures. You know, if I wanted to round that number and said, round 243 to 2 significant figures, I would need to, cut that off right there. But I can't add in a decimal because that would change that number. I would have to round 243 to 2 significant figures, which if I rounded to 240, now it would have 2 significant figures. These numbers would both be significant, but the 0 would not be significant because our rules say that zeros that come after numbers are not significant unless there's a decimal, and there'd be no decimal in there, so that would be 2 significant figures. All right, if we have a number like 0 points, and as far as significant figures, these are placeholder zeros. If I'm writing a number, that 0 there is not significant, that 0 is not significant, that 0 is not significant, because they're all leading zeros. There's not any non-zero numbers yet. The first number, if I write a 2 here, that 2 is the first number that comes significant in our rules. So far this number would have one significant figure, just that 2. If I add a 4 there, now it would have 2 significant figures. And then if I put a 0, would that 0 be significant? Well, my rules say that zeros that come after, at the end of non-zero numbers, are not significant unless there's a decimal. That decimal makes that 0 significant, so that would be 3 significant figures. Now, if I had a number like 5,400, and my rule says that zeros that come after numbers are not significant unless there's a decimal. Those 2 zeros would not be significant, so that would only be 2 significant figures. Now, if I added a decimal in there, if I had 5.400, now my rule says zeros that come after numbers, like these last 2, are not significant unless there's a decimal. That decimal makes those 2 zeros significant, so that would be 4 significant figures. Now, if we look at a number, the way I told you to tell if a number, how many significant figures it has, if I have this number 0.000700, well, 70010. Tells you to go to your first non-zero number, which in this case would be 7, draw a line in front of it. All these zeros here are just placeholder zeros, they're leading zeros, they are not significant. Then put a line after the last non-zero number, the 1 there. All the numbers inside the red lines would be significant. And these 2 zeros here, because they're captive zeros, they're in between the 7 and in between the 1. Now this last 0, would it count? Our rule says that zeros that come after numbers never count unless there's a decimal. That decimal right there makes that 0 count, so that would be a total of 1, 2, 3, 4, 5 significant figures. Now if we had another example, if I had 80,040. Alright, I draw a line in front of the first non-zero number, which is 8, a line after the last non-zero number, which is a 4. Everything in between there, the green lines, is significant. Those zeros are because they're captive zeros, they're embedded zeros. So it'd be 4 significant figures. Now we have to look at this last 0. Our rule says that zeros that come after non-zero numbers are not significant unless there's a decimal. There's no decimal, so that number would not be significant. That would only be 4 significant figures. Now, when we talked the other day, yesterday about adding and subtracting. All right, if we add and subtract, we go by the fewest amount of decimal places. We don't even look at significant figures when we add and subtract. You just look at decimal places. So even if you didn't know how to figure out the number of significant figures, it wouldn't matter. We just call it adding and subtracting to the rules of significant figures. Even though we don't go by significant figures, we go by decimal places. So if I had 34.27 plus 18, we have to go with the number with the least amount of decimal places. This top number here has 2 decimal places, so that would be 2 decimal places. This number here has 0 decimal places, so our answer needs to be to no decimal places to them. So when we wrote our answer, we get 0.27, and that would be 52.27. We would round this to no decimal places, so our answer would be 52.27 would round just to 52. So 52 would be the correct answer if you're going by the correct number of decimal places. We look at one more example, and this is still just a review. We had 7.43899 and subtract 3.5 from that. If we work this out, we would get 9,983,9 6.93899. But what's the way we're supposed to round our answer? Well, since we're adding and subtracting, we would go by the least amount of decimal places. This one only has 1 decimal place. We should cut our answer off to 1 decimal place and make it match up with that one. So 6.93, the 9 would stay the same because it's a 3 there, so that would just be 6.9 would be the correct answer, 1 decimal place. Because in our 2 numbers here, that one had 4 decimal places. This one had 1 decimal place. We have to match up our answer to have 1 decimal place if we go by our rules of significant figures. But now we want to talk about multiplying and dividing. Adding and subtracting is easy because you just go by decimal places. Multiplying and dividing, we don't. We use this, the answer should be rounded to the least number of significant figures in any of the factors. Example, 23.0 centimeters times 432 centimeters times 19 centimeters, you get this big long answer here. But I got to round my answer to the correct number of significant figures because in science we need to all get our answers right. We don't have to need to have calculations rounded to different decimal places. It'd be confusing communicating information, so we have to have certain rules to go by. Well, our rule for multiplying and dividing numbers is we look at the numbers that we multiply and divide, and the one with the least amount of significant figures, we match up our answer with that number of significant figures. 23.0 has 3 significant figures. 2 and the 3 is significant. That 1 significant because there's a decimal there, so that's 3 significant figures. 432 has 3 significant figures. 19 has 2 significant figures. So our answer, if it matches up with the least amount of significant figures, would be it needs to have 2 significant figures rounded. So how can we round 188,784 to 2 significant figures? We would need to cut that off right in there somehow, but not change the number. We need to round it. So we could round the 1/8, could round up, 1/8 is significant, and we couldn't do it to 100. Well, we could round the 8, would make that 8 round up, and we could round it to 190,000. That number would have 2 significant figures. The 1 and 9 is significant, and the rest of them are not significant because there's no decimal. So that would be the correct answer. But if it's kind of hard to look at it that way for you, sometimes if you have a number that's got 4 or 5 significant figures, like 188,784, and you want to round it to a lower number of significant figures, put it in scientific notation. If I put 188,784 in scientific notation, it would be like 1.88,784 times 10 to the, and that would be, see if I move my decimal from the end, it'd be 1, 2, 3, 4, 5 places. I see that answer's wrong anyway. And I need to have the 2 significant figures. I don't look at scientific notation when it comes to significant figures. I would need to round it here. So that would end up being 1.88 would round. I need 2 significant figures, so I'd have to round it up to 1.9 times 10 to the 5th. And that would be the same number as 190,000. And that would be 2 significant figures. It just takes some practice for these. If we look at some more, this top example, 342 times 27, and we get that equals 9,234. Well, 342 has three significant figures, 27 has two, so our answer only needs to have two. We're going to have to cut it off somewhere in here and put zeros, so our correct answer would be rounded to 9,200. That has two significant figures, or putting it in scientific notation and round it to just those two significant figures. That would be also correct. Our next example, we got 9.723, that is four significant figures, divided by 2.79254, that's got 6 significant figures. We got to match it up with the least amount, so our answer needs to have four significant figures. How can we round? 3.481776, saw that? Well, we need four significant figures, we're going to have to cut it off right there. So we'd have to round that, that'd be 3.48. The 7 would make the 1 round up, so it'd be 3.482. That would be four significant figures. You know, if we needed to go down to three significant figures, we'd just take the 2 off and have 3.48. Our next example, 0.031, that would have two significant figures because these are leading zeros, they're not significant, times 0.0004, that's got one significant figure because those zeros here don't count. And what you get is 0.0000124. All right, our answer needs to match up with the least amount of significant figures, which was 1 in this case. How can we round 0.0000124 to one significant figure? This is why placeholder zeros are not significant, these right here, because if they were significant, the answer would end up being just 0.0. That's why placeholders and leading zeros are not significant. We need that one significant figure, we're going to have to cut it off right here. So our answer would be 0.00001. That would be one significant figure. You could have also put that in scientific notation if you'd wanted to. Okay, our next example, 1,004. That would have four significant figures because the two zeros are embedded, so they would be significant. Divided by 230, that has got two significant figures. So our answer needs to have two significant figures. When you work it out, you get 4.3652. Rounding that to two significant figures, we'll have to round it right there, and that becomes 4. The 6 would make the 3 round up. 4.4 would be the correct answer to the correct number of significant figures. All right, let's look at just a few more examples. If we had 26.48 times 14.2, and we're going to do this work in our calculators. All right, and if I take 26.48 times 14.2, I get 376.016. Now that answer has 6 significant figures, but I got to match up the answer with my least accurate number that I multiply by, the one with the least amount of significant figures. This number has 4 significant figures. This number has 3 significant figures, so my answer needs to have 3 significant figures. How do I do that? Well, 3, 7, and 6 is all significant. I could cut it off right there and round, and my answer would just be 376, and I could leave off the 0.016 because that would have 3 significant figures right there. If I would have left the 0.0, that number there would have 4 significant figures because that last 0 would be significant because of the decimal. That would be incorrect. I'll need to just round it to 376. So if we look at another one, if we had like 5,400, and we want to divide that number, and write these examples down, that way you'll have something to go by. If we wanted to divide that number by, let's say 127, we punch that into our calculator. If we have 5,400 divided by 127, that would equal 42.5196. 685. Now, how we should round? Well, if we look, 54.0 only has two significant figures because those two zeros do not count because there's not a decimal in there anywhere. 127 has three significant figures because 127 is all non-zero numbers. Our answer needs to have two significant figures. So how can we round 42 to have two significant figures? We have to round it right here. The 42.5 or whatever, we round it up to 43 because of the 5 would make the 2 round up. That would have two significant figures. That would be a good answer there. All right, so one or two more real quick. If we have 0.304 divided by 0.002. We punch that in our calculator. First, before we even do this, let's see how much significant figures our answer needs to have. If we look at 0.3004, that number would have three significant figures. This first zero would not be significant because it's a leading zero. Divided by 0.002, these zeros are not significant because they're leading zeros. This would only have one significant figure. So our answer needs to have one significant figure. So we take 0.304 and then divide that by 0.002. We get exactly 152. How can we have our answer have one significant figure? How can we round 152? Well, we would have to round it right there, and we'd have to either round it down to 100 or round it up to 200 to make it have one significant figure. That 5 would make the 1 round up, so our answer would be 200. Another way of looking at that would be, well, if it's hard for you to look at it and visualize how to round something to one significant figure, you can always do this to a number. If you have 152, put it in scientific notation, which would be a decimal here, 1, 2, that would become 1.52 times 10 to the second since I'm moving to the left. Rounding that to one significant figure, I would have to cut off here and round. 1.52 would round to 2. Now I could 2.0 would make it a two significant figure, so I just need to leave it as 2. That would be 10 times 10 to the second. 2 times 10 to the second is the same number as 200, and they both have one significant figure. So both of those answers would be correct. All right, so one more real quick. If I have 4,000.50, now multiply that by 2,500. First of all, before we do this, let's see how many significant figures our answer needs to have. If we look at this first number at the top, all these zeros are significant. This zero is significant because there's a decimal there, so all those numbers are significant. So that'd be 1, 2, 3, 4, 5, 6 significant figures. 2,500, these zeros would not be significant because there's not a decimal in there, so that would only be two significant figures. So our answer needs to have two significant figures. So then we'll do the calculation. 4,000.50 times 25. 4,000.50 times 2,500. We get 10,001. That's 200. Well, that'd be 10,001,250. So we need that to have two significant figures. To do that, we just about have to put this in scientific notation, because if we cut it off right here and rounded it to 10 million, that would only be one significant figure. We need two significant figures. So what I would recommend is to put it in scientific notation. You got a decimal here at the end, move it 1, 2, 3, 4, 5, 6, 7 places till you get to a number between 1 and 10. That would be 1.0, or that'd be 1.0 times 10 to the 7th power. That 1.0 would have two significant figures because of the 1. That 0 would count because there's a decimal there. So that would be the best way to handle a number like that. So do the worksheets, help each other, work together, put some problems on the board if you need to. And we're gonna do, like I said, plenty of work with this today and tomorrow on our study guide as we get ready for a test in a few days.